Bismillahirrahmanirrahim. Today we are going to speak about the motion on a curve and finding the velocity and acceleration of vectors for some moving particles. So assume that we have a curve or opposite, and there is a particle is moving on this curve. The particle is indicated or determined by some vector called the position vector for some given time. As the time is changing, the position of the particle is changing, and based on that also the velocity and acceleration also is changing. So let's start with the position vector. If r and the notation it is f of ti plus g of tj is a position vector. Then vt or v of t, which is equal to the first derivative, is equal to f prime of ti plus t prime of tj. And a of t vectors is equal to the second derivative of the velocity and the acceleration of the particle. And also the magnitude of v of t is the speed of the particle. So, if we are given the position vector, we can find the velocity, which is equal to the first derivative. But the position vector is a vector valued function. So we can differentiate that one to find the velocity, and the second derivative will give me the acceleration of the particle. For example, with that we have a particle moving along the given or some given curve. So with that, move along. X equal to 4 cosine t and y equal to 4 sine t. Z equal to 60. Where t is the time. Find the magnitude of the velocity and acceleration. T equal to pi over 4. Okay. So we have a moving particle on a curve given by the parametric equation x equal to 4 cosine t, y equal to 4 sine t, and z equal to 6t. We need to find the magnitude of the velocity and acceleration. So the position vector will be given by is equal to x, y, z, which is equal to x is given by 4 sine of t, sine is 4, y equal to 4 sine of t, and z equal to 6t. So this is the position vector. We need to find the acceleration and velocity first, then we can find the magnitude at the given time t equal to pi over 4. So the velocity v of t, which is equal to the first derivative at t equal to pi over 4. Let's find the derivative for this one, and then evaluate at t equal to pi over 4. So the derivative of 4 cosine will be minus 4 sine t. 4 sine will give me 4 cosine t, and 6t is 6. The derivative equal to 6. Now at t equal to pi over 4, we will evaluate this one at t equal to pi over 4. I will have just substitute, maybe minus 4, 4 and 6. When we replace t by pi over 4, so it is not. Sine pi over 4 will be minus 4 multiplied by square root 2 divided by 2. Cosine pi over 4 will be multiplied by root of 2, and last one is constant for z, which is equal to 6. So this is the velocity at the given time, t equal to pi over 4. And the magnitude for velocity now is equal to or I can just say at pi over 4. It is minus 2 root of 2 square plus 2 square root of 2 square plus 6 square. It is 8 plus 8 plus 36, which is equal to square root of 52. So the magnitude of the velocity at t equal to pi over 4 equal to square root of 52. Now for the acceleration, is equal to the second derivative. The second derivative is equal to minus 4 cosine of t minus 4 sine of t and 0. This is the first derivative, so the second derivative will be minus 4 cosine. This will give me minus 4 sine, and the derivative of 6 is equal to 0. It is constant. So this is the acceleration. Now at t equal to pi over 4, or the acceleration in this case, pi over 4 is equal to minus 4 multiplied by cosine pi over 4 is square root of 2 divided by 2. Sine pi over 4 is 2 over 2, or square root of 2 divided by 2, and z is 0. So the magnitude of the acceleration now is equal to it is 8 plus 8 plus 0, which is equal to square root of 16, that will be 4. So the magnitude of the acceleration is equal to 4. Remark. A particle moves in a constant speed. Let's see. Then its acceleration vector is perpendicular to the velocity vector. Acceleration vector, let's say A is perpendicular to the velocity vector V. or if we have a particle is moving in a constant speed c, then the acceleration vector A is perpendicular to the vector or velocity vector V. We can say that their cross multiplication is equal to 0 or their dot product equal to 0. Just one more example. Find the velocity acceleration and the speed. And to find the velocity, acceleration, and the speed at the indicated time, where the position vector r of t equal to 2 cosine t I plus, say, 1 minus sine of t g at t equal to pi over 3. Now, the velocity we say it is the first derivative, acceleration is the second derivative, and speed is the magnitude of the velocity. It is the magnitude of the velocity. When we see this word speed, means we need to find the magnitude. So the velocity of t is equal to the first derivative, which is equal to minus 2 sine ti minus cosine of tj. So v at pi over 3 is equal to minus 2 sine pi over 3 is square root of 3 divided by 2 I minus cosine of pi over 3 equal to minus 1/2 j. From this one you can find the speed. Equal to the magnitude of is equal to 3 plus 1 over 4. Or it is 13 over 4. This is the square root of 13 divided by 4. So this is the speed of the particle. Now for the acceleration. Equal to the second derivative of t. Or it is equal to the first derivative of v of t. That will be minus 2 cosine of ti plus sine of tj at pi over 3. This will give me minus 2 multiplied by 1/2 I plus square root of 3 divided by 2 j. which is equal to pi over 3, sine pi over 3 equal to 1 half, and sorry, square root of 3 divided by 2, and cosine pi over 3 equal to 1 half. So this is the acceleration at time equal to pi over 3, or we can write it as minus I plus square root of 3 divided by 2j. So this is the idea of the or finding velocity and acceleration of a moving particle. We have a position vector, just we need to find the first derivative and second derivative that will give me the acceleration and velocity vectors. And we can find the magnitude or the speed of velocity.